did, but that's okay.
Okay, so what about in 6 hours? How much of the job do you complete?
The whole thing?
The whole thing, because 6 over 6 is 1, right? How about in 2 hours? How much of the job do you complete? A third, right? Because 2 over 6. Now, we may not just know that off the top of our head, but now that we realize, oh, 2 over 6, and then I'm just reducing. So, when we think about these word problems, each of the parts are going to be made up by thinking about the fraction of work that each person does in a certain amount of time. So, think about the work done by person number 1 plus the work done by the second person equals the whole job. Make sense? So I do some work, Leanna does some work, together we're doing the whole job. So the time spent is on top, just like the things we just did where we said like 3 out of 6, 2 out of 6. Okay, that's going to be on top. The time on the bottom is how much time that person would need to do the job all by themselves. And then the other fraction is going to be the time spent over how much time the second person would need to do it by themselves. So if we read this bottom question, it says, if Ryan can fill the order in 10 minutes working alone, and Crystal can also fill it in 10 minutes working alone, how long would it take them if they were working together? Okay, so you just know it's 5 minutes, right? So let's see if we can set that up and find it out algebraically. Kind of proves to us that the system works. So we don't know how long it takes them individually. I know you just told me, but we're going to pretend that we don't know yet. So that's our T. We said it's 10 minutes for Ryan to do it alone, and 10 minutes for Crystal to do it alone, and the whole thing is one job. Now, to get rid of the fraction, what will we multiply by?
10.
By 10. So this guy's going to get multiplied by 10, this one gets multiplied by 10, and that one gets multiplied by 10. So these 10s, we all agree this is just gone, right? So that's T plus T. 10 times 1 is 10. And then we know that T plus T is 2T. Equals 10. Divide by 2. And sure enough, just like what you thought, it would take 5 minutes if they're working together. So you might say, why do I need to use this? I could just figure that out. Well, they don't usually both take the same amount of time to do it. Okay? So usually one person might work slower than the other person. One person might work faster. So we're going to look at what if in this same problem, Ryan's a little slower at the job. What if it takes him 20 minutes to do it alone? So our setup's going to look similar. It's still, we're looking for the T on the top, right? We're looking for the time together. So T over Ryan is going to be T over 20. So if they work 1 hour, Ryan's getting 1/20th of the job done. If they were, or 1 minute, I should say. If they work 2 hours, he would be getting 2 out of 20, so on. And then Crystal's still doing it 10 minutes. So this is Crystal's work. So the T over 20 represents the portion that Ryan's doing. The T over 10 represents the portion that Crystal's doing.
You give me too much credit.
And that equals the one job that they're doing. Now what do you think I should multiply by to clear the fractions? So we're going to multiply. What's the biggest fraction I see? 20, right? I'm going to have to multiply by 20 or the fractions aren't going to go away. So every part of this equation times 20. So a times 20 here, a times 20 here, and a times 20 here. Or if you prefer to rewrite it, these 20s are gone. This is just T. How many times does 10 go into 20? 2. So this is now 2t, because basically Crystal's doing twice as much work, because working faster. And then 20 times 1 is 20. T and 2t would add up to be 3t.
Wait, how did you simplify that so quickly? I thought you would have to multiply, if it doesn't cancel out, you would have had to multiply.
Well, what's 20 divided by 10?
2.
That's where the 2 came from.
And then you just bring your t down.
Mm-hmm.
Oh, so if it doesn't multiply, you divide.
Yes, yes. So the bottom number, the bottom of a fraction means divide. So that's like 20t divided by 10 gives us 2t. This is why I said we're going to need calculators, because they are going to come out messy like this. So now we need to do 20 divided by 3. Okay, so we're going to round to the nearest hundredth, which means we're going to keep 2 decimal places. So that's going to round to 6.67. We're keeping 2 places. So 6.67 minutes. Now, does that make sense compared to our other answer? Now, this time, one of them is still working as fast as the other one's slower. So the time should be between that 5 that we got before and the 10. Right? It shouldn't be. So 6.67 is reasonable. It's not going to be as fast as it was before because Ryan's not doing as much work. All right, so let's go on to our backside.
Miss Carolyn.
Oh my goodness. So just giving you a different kind of application. If Miss Carolyn can grade the papers alone in 30 minutes and Ms. Miriam can grade them alone in 45 minutes, how long would it take them to grade the papers if the teachers work together? So, we're looking for that time together, right? So that's going to be our variable. So we can use t, we could use x. Doesn't really matter to me what variable you use. So if I say that's x, if I'm person number 1, Miss Carolyn, I need 30 minutes. So I've got x over 30. What's the second fraction look like?
T over 45.
Okay, so if I used x, then use x.
Oh, X, sorry.
It's okay. I mean, if you use t in both cases, just don't use 2 different ones. Doesn't matter if it's x or t, but we have to choose. Equals 1. Now, some of you might say, like 30 and 45, what would cancel with those? You know, you can just multiply them both by 30 and 45. But the smallest thing would be 90, right? 90, 30 goes into 90, 45 goes into 90.
We don't take the biggest one like we did on the last page?
Does 30 go evenly into 45?
No.
That's why we can't take that. So it's like a common denominator. Now, I want to show you something. For those of you who would come up with 90, you can go ahead and try to finish the problem. You're going to be fine. For those of you who are like, I have no idea where 90 came from, and I'm uncomfortable, and I'm never going to be able to do this, I want to show you, we could do this. The answer comes out the same. 30 and 45. 30 and 45. Okay? So we're multiplying all of them by 30 and by 45. But this first one has a 30, so the 30 would cancel, right? This would become 45x. This one, the 45, would cancel, and I would have 30x. Now, the 1 has to get multiplied by both of them if you do it this way. So you have to do 30 times 45. What do you get?
30. No, wait, 30 times.
30 times 45.
13.
You're asking me to big numbers in my head, not good.
1350. You have calculators. 1350, right?
Mm-hmm.
Okay. Then what do I need to do?
My like terms first.
Yeah, combine the like terms. So 30 and 45 make 75x. equals 1350. And then when you divide by 75,
You get 18.
does it come out nice and even?
I divided by 75, it said 18.
Yep.
Yeah.
Yep.
No.
18. Did anyone finish it out using 90? Did you also get 18 minutes? Yes. Your numbers were smaller, but when you divide it, it all turns out the same. So don't get too hung up on finding, like, I can't come up with the smallest thing. Just go ahead and use both the numbers if you want. It still turns out the same in the end.
So as long as we use all the denominators in the fraction,
Yes.
we can go along and just basically go multiply this by this, but those cancel out.
Yes, as long as you cancel correctly, it turns out the same. It's like when you had to do fractions. If you were adding regular fractions, you could use a bigger denominator as long as you reduced at the end. When we divide at the very end to solve, that's like reducing. Okay, so in this next part, we got an extra number here. We need to figure out if we need that number or not. It says if Miss Carolyn can grade 25 papers in 30 minutes and Miss Miriam can grade the same amount in 45 minutes, how long will it take to grade the papers if the teachers work together? Okay. Now, my first instinct, honestly, even though I've done a lot of math, if I haven't done these problems in a while, I start trying to use that 25, and it makes the problem a lot harder. Can we agree that since I'm grading 25 papers and then it says the same amount, that is the one job? So basically, as long as it's the same, it says she's grading the same amount, we will not need that 25 for anything. Okay? We won't need that 25 for anything. We're just back to the same thing that Miss Carolyn's time. So the time together is what we don't know. That's what's on top. I need 30 minutes. Ms. Miriam, it says 45 minutes. Is this the same problem we just did?
Yeah.
Yeah, so guess what? The answer is still 18 minutes. Okay, it's the same problem. We do not need to use that 25. Okay, so just consider that the 25 papers, that represents the one job. All right, now we got Taylor and Aspen, and they are cleaning a house. Now this one's a little different because notice it says working together, they can clean the house in 2.4 hours. So our X's should not be on top. The 2.4 is what belongs on top. Does everyone see why? Working together, Taylor and Aspen can clean the house in 2.4 hours. So that is the time together. So 2.4 is on the top.
So the time's always on top.
The time together, the time it takes together is on top. The time it takes them each alone is on bottom. Together's on top, alone is on bottom. And then it says that Taylor could do it alone in 2 hours, which I made a bad problem here because this does not make sense. This means that Aspen is distracting her greatly. If it took longer with help. Let's make Taylor 4 hours. Sorry, guys. I tried to make up these questions at the last minute.
It shows just the fact you use my name, your name. It's like.
Okay, so we're going to make this Taylor into a 4. Taylor is 4 hours. So 2.4 out of 4 plus Aspen's also working 2.4. That's the time they're working together. But we don't know how long it would take Aspen by herself.
That's what we're trying to find.
That's what we're trying to find out. That's where our X is. And it still equals the one job.
So this time you only have one variable to worry about.
and I just erased everything. So I'm going to catch up. So time together was 2.4. I'm just rewriting what was already up there. Taylor's time alone was 4, plus time together is still 2.4, and Aspen's time is what we're looking for, is equal to 1. So what do we need to multiply by? What's our lowest common denominator?
4.
4, and we need to get rid of the 4 and the x, right? So we need to multiply everything by 4x. So
Our LCD. Like
that's your LCD, yep. So this we're doing 4x times the 2.4 over 4 plus 4x times the 2.4 over x
How'd you get 4x out of that? I mean,
and 4x times the 1. What's in the denominators to start with?
a 4 and x, but that's 4 plus x.
No, it's not 4 plus. We're multiplying the denominators. If it was a 2 and a 3, I wouldn't use a 5. I would use a 6. I have to have something that cancels.
the 4.
So here, the 4's cancel. We're left with 2.4 times x, which is 2.4x. Here, the x's cancel. What's 4 times 2.4? 9.6. And then 1 times 4x is 4x. Okay, do we know how to solve a problem like that? Yes, it's a little different setup, but we do know how to solve that. So I'm coming up here to the top. So I'm just going to write, I have 2.4x plus 9.6 equals that 4x. I got to get those x's on the same side. So we're going to subtract 2.4x, right? So that's 1.6x. And then you're going to divide. Actually, that means you're really slow. So it says 6, right? That's how long it takes you to do the job by yourself. It takes you 6 hours to do it by yourself. So getting a bigger number there, it doesn't mean you're faster. That means you're slower, actually. All right? So Aspen takes 6 hours. Yeah, when you do your homework, you're going to write a sentence. I can barely write numbers, so. Okay, so your homework are all going to be ones where they are work, but if you notice, you could have different, it could not just say people working. You could have hoses draining something. That is still the same kind of thing. We're still talking about the hoses basically are what's doing the work. So if one hose can drain it in 9 hours alone, does alone time go on top or bottom?
Bottom.
On bottom. Alone is on the bottom. So we know the 9 is on the bottom. And then it says when she hooked up a second hose together, they drained the pool in 2.25 hours.
Who's they?
They is the 2 hoses. You're using 2 hoses.
Mary friend.
No. So the 225 is a together time, so it's on top. So this is the work of the first hose. The work of the second hose is still the together time is on top. And we don't know how long that second hose would take by itself. That is our X. And it's doing one job.
Can there be more than one job?
There could be. But there's not on any of your homework. So what would I multiply by? Leanna? 9x. I need to multiply by something that would cancel with both of those. If we try to do x plus 9, that doesn't cancel. Remember, x plus 9 is like 1 unit. It would not cancel with a 9 or an x. So each part is going to get multiplied by 9x. So I've got 9x. And if you have room that you want to write it right next to it, I'm doing 9x times this plus 9x times the 225 over x equals 9x times 1. And then we need to go back and start doing our canceling. So these 9s, that leaves us with 2.25x. These x's cancel. And then what's 9 times 2.25?
20.25.
20.25. And then this is just 9x, right? Yeah, we got to get our x's on the same side. Even though I'm inclined to have my x's on the left, since there's not any numbers on the left, it's going to be shorter to put the x's on the right. So we're going to subtract the 225x from both sides. That's going to leave us with 20.25 is equal to 6.75x. No.
No?
I subtracted 225,
Oh, okay.
right? And then last step, we're going to divide both sides by 6.75. Three. So the second hose apparently must be a lot bigger. It's draining it much faster than that hose that she had to start with that would take 9 hours by itself. So the second hose takes 3 hours alone.
I don't have a tablet that large, but I do have a tablet.
Okay, we are going to pick up with the 4.6 rational equation application notes and think about the setups that we talked about on the other handout, where we had our together time on top and our alone time on the bottom. So in this case, we have Beth and Daryl. Notice it tells us Beth can pick 40 bushels in 12 hours. Daryl can pick the same amount. So do we need the 40 for anything?
No.
No. So we will get rid of the 40. See, when you can just like mark out a number, life seems like it's getting easier. Okay? So, what is Beth's alone time that it would take her? For Beth. So Beth would take her 12. We're looking for the together. You're fine. So this represents the amount of the job that Beth is doing. Now, for the amount of the job that Daryl is doing, we also don't know the together time, but we know Daryl by himself takes how long? 8 hours. And we're going to say they are doing one job. We're going to call that 40 bushels. That's one job. Now, again, some of you may be good at coming up with what would be the lowest possible common denominator, but this will work every time. As long as you have a calculator handy, it's not going to be a big deal that the numbers get large. Go ahead. You see a 12 and an 8? We can just use a 12 and an 8. A 12 and an 8. If you are doing 24, congratulations. You came up with what would be the lowest possible. If you do 12 and 8, though, look what happens. Oh, got to remember to do the 1. Times 12 and times 8. The 12s here cancel. This is 8x. These 8s cancel, making that 12x. Some of you may say, is it the same thing as if I use 96? Yes, it's the same thing. And 12 times 8 times 1, that does give us 96 over here on the right.
Oh, I put 18. So combine the like.
Combine the like terms. Thank you, Dalton. So that makes 20x is equal to 96. And when we divide, 4.8. So x is equal to 4.8. So together, it would take, or it takes, how many hours? 4.8. 4.8 hours. Does that seem reasonable? It better be a shorter amount of time, right? Okay, so one of them takes 12 hours. One of them takes 8. It better be shorter. If I had two people who both took 12, the answer would be 6. If I had two people who alone both were 8, it would be 4. So the answer needs to be between 4 and 8. Or 4 and 6, I'm sorry. So 4.8, we're good.
Okay, so would a reliable method of determining the amount of hours for them, would be just to minus the two values?
Is 12 minus 8 equal to 4.8?
No, but it
No.
is equal to 4.
Yeah, we
But-
gotta put the 8 in there.
But 4.8 hours isn't the same as 4 hours. And that's kind of coincidence that that's even that close.
Oh, okay.
A reliable estimate would be to take half of 12 and half of 8. Half of 12 is 6. Half of 8 is 4. It has to be between 4 and 6. Okay? That's a reliable estimate, but it's only a range. It's not the whole answer. All right, and number 2. Wow. Okay. The first person can weed the garden in 15 minutes. What would the fraction be that represents the amount of work that person is doing? X over 15, yes. X over 15.
And I'd like to know how they're doing that unless there's a flash.
Maybe they have a really small garden.
Or they leave like every 2 weeks.
Maybe. And the second person, X over 10. And they're doing one garden, so one job. So equals 1. It needs to be an equation, right? So we could use 30 because that would be the smallest number. But if that, I don't know how you got 30. Remember, you could do both of them times 10 and both of them times 15, which basically just multiplies them times their one that they're missing, right? So what would you guys prefer we multiply this by?
10 and 15.
10 and 15, just keep it simple that you can use that rule every single time?
Yeah.
Okay, so if I write 15 and a 10 here, 15 and a 10 here, X over 10, and then 15, it's teaching the old dog new tricks here. And this is times 1. So, this first one, the 15 would cancel. This one, the 10 would cancel. So, Dalton, what after I cancel, what does my equation look like?
10x.
10x. What? Keep going.
Plus 15x
Mm-hmm.
equals 150.
150, good. And then we combine like terms. 25x is 150. We divide. This one comes out nice and neatly, right? 6. And so what is that 6? What was the question? If you're ever not sure what it is, what was
Oh, 6.
how long it would this one is minutes, right?
I did too at first and I erased it.
Okay.
I would like to point out another coincidence in this case. If we were to minus both numbers, it would be only 1 minute off.
What?
If you minus 10 from 15, it equals 5, which is only one number.
So on this problem, instead of looking for the time that they're working together, we are given the time they're working together. So our variable will not be on the top of our fractions. So this will be, together is on top, so 5, go away. So the 5.09, is that what that says? I don't know. I don't know how I got that.
It is 509.
It is, right? Okay. That's their together. So both of them will have 5.09 on top. And what's the first person's name?
Paul.
Paul. Do we know how long it would take Paul by himself? No, that's what we're looking for. Catherine by herself is 14. By the way, it wouldn't matter which place we put the x in. 14 is going to be on the bottom of one, x on the bottom of the other. And again, they're doing one job. So we're going to multiply everything by 14x. 14x, that's right. So each part is going to get multiplied by 14x. So when I do 14x here,
There.
the x's are going to cancel. What is 14 times 5.09? 70 what? 71.36? 26?
Hey, I'm sorry, don't.
Where'd it?
And then when we take the middle part here times 14x, 14 cancels. That gives us 5.09x. And then 1 times 14x, 14x. What's your next step going to be?
Minus the 5.09.
Exactly. Subtract the 5.09x on both sides. I would still then have 71.26 equals what? 8.91? Is that right?
Yep.
8.91x. And then we would divide.
By 8.9.
Yes. The number with the x should be the one going in your calculator second, right? So 71.26 divided by 8.91 is a nice 8, right? Nice.
Round
Oh. So 7 point how much?
up. 9.
I didn't get
Just 7.99? 99 and then a 7. So we would round it to 8. Because we said nearest hundredth. So that's like saying nearest cent. If something was 7.99 and then a 7, that would jump up to being a whole 8. Or 8.00 if you want to write it that way. Okay, take a moment and work out number 4. And then we'll check to make sure you've done the right thing. All right, so hopefully your setup looks similar to mine, but maybe neater. So 5.63 is the time that they worked together. So that's on top. 9 hours is Molly's alone time. And we don't know her friend Mary's alone time. So the second fraction has an X on the bottom. So the first fraction represents the work that Molly's doing. The second one represents the work that Mary's doing. And together they're doing a whole job. So we're going to multiply everything by 9x. Our 9's cancel, giving us 5.63x. And then what is 9 times 5.63? 50.67. Thank you. And that equals 9x. So then, of course, we need to subtract. So 50.67 equals 3.73x, right? No, 3.37. Miss Carolyn just became dyslexic. Oh. And then we're going to divide. I won't try to do that in my head. Someone tell me, what did you get?
15 hours and 3 minutes. That's what
Okay, whoa. 15 what? 15.03?
5. Yeah.
15 point what?
0.
035.
So you round up.
That it's actually 15.035, so you round up to 15.04.
15.04. Does that mean 15 minute? Well, first off, these are hours. So it does not mean hours and minutes. Okay, are there 100 minutes in an hour?
6. No.
No. Are there 100 seconds in a minute? No. Do not think that the decimal means like minutes and seconds or hours and minutes. The decimal doesn't mean that. Like a quarter of an hour is not 25 minutes.